September 27, 2014. We have a strong Earth-facing flare in progress. This is the X-ray flux data from Boulder. You can see that it's now at an M. It will peak at an M.5. Excuse me, an M5. Now, a couple of charts I want you to pay attention. This is what's called the TEC, the total electron content of the region. This is from one of our satellites from the Australian government. Notice that is peaking over South America. But, again, I'm just going to be bouncing back and forth to this chart because it's in progress. And as I started seeing this, we started getting SDO images, and I'll show you those also. Now, I did a video last night talking about the unstable surface of the sun. And this is the first image of the flare, and this is from a still image. It came in first. I went back and checked. Now they're putting it into the MPEG movies from the SDO. But again, Earth facing. Let's watch this. There. Now, guys, we already have Japan volcano, Iceland volcano, a couple others around the world. We're seeing the swarm of 600 quakes, Mammoth Lakes. Again, I'm flipping back to this X-ray flux chart, and I'm going to show you also the 1 minute. But last night we talked about sometimes we'll have large sunspots that are beta, gamma, delta. Sometimes we'll just have filaments, and they seem to rotate as far as both aren't combined all the time. But right now we do have that combination: large filaments across the sun, large sunspots. If you take a look at this, the flare came from the bottom right corner. Now this is a 1 minute chart, and this is more accurate. This will give you a closer number than the 5 minute data because you can see the curvature and you can actually see the peak of this M flare. It didn't reach X flare status, which is good because it's so Earth facing. Now look at the M5.1 is the current status, and it has dipped. That's where it peaked, at the 5.1. We're going to have to watch that sunspot because we've seen them fire off multiple flares before. Here's the other chart that's important. This is called the real-time simulated global layer absorption. Notice where it's at, Australia, and the Sumatran Trench going up under Japan, but that Sumatran Trench area is dead in the absorption layer peak in that chart. Again, your beta, gamma, delta is 2175. That's not where we got the flare. That's the one that's supposedly giving us a 10% chance of X flares, but 2172 is, notice it's 2 sunspots, and that's probably where we're getting this combination of energy for these flares. We're going to update this, and one thing I want to say, usually when we see a flare that strong, in the next few images from either stereo A or B and the SDO and SOHO, we will see if there's an associated coronal mass ejection. If so, that's going to increase the tectonic plate pressure that we already have. But this flare will deliver heat energy into the ionosphere of the Earth through the magnetopoles, our shields, and that will be absorbed into the crust and mantle of the Earth. So heads up, we're going to watch it again. Watch for the CME. Be safe.